Question number 5, when we're going through our test and we're reading it, it says, an object has a moment of inertia of 2.56 kilograms times meters squared. So, I equals 2.56 kilograms times meters squared. What is the value of the torque needed to accelerate the rotation of the object from rest to a rotation of 5 revolutions per second in 30 seconds? So, we're looking for torque, and it says originally we have an object that starts out at rest, so V initial equals 0, and it goes 5 revolutions per second in 30 seconds. So change in time equals 30 seconds. So the first thing you want to do is realize, well, this is a chapter 10 question, this is inertia. We know that the general formula for inertia is equal to mr squared. Well, Dr. Sullivan was nice enough to tell you already that inertia was already equal to 2.56 kilograms, radius is in meters, so it's squared. That's what we get with our inertia. Now you have to recall, this is a great formula to have in your formula sheet, that torque is equal to inertia times angular acceleration. Well, we already have inertia because Dr. Sullivan gave it to us, so now we're looking for the angular acceleration. And that's where all of these components come into play. This should actually be omega, right? Because we're dealing everything in angular velocity. So essentially, we have to recall from our previous knowledge of chapter 9 in rotational motion, how are we going to solve for the angular acceleration of an object? Well, we know that the initial angular velocity is 0. It's traveling at 5 radians per second, and the time is 30 seconds. So the first thing we want to do is change 5 revolutions per second into radians per second. So if you recall, to go from revolutions per second to radians per second, multiply by 2 pi radians per 1 revolution. And that gives us 31.42 radians per second. So, after 5 seconds, we know that our angular velocity is equal to 31.42 radians per second. So, recall from chapter 9, we have final angular velocity equals original angular velocity plus angular acceleration times time. So here we're looking for our angular acceleration. We have our angular velocity finally, which is 31.42 radians per second. Initially it was at 0 radians per second, plus acceleration times a change of 30 seconds. So if we divide 31.42 by 30, we get an angular acceleration of 1.047 radians per second squared. So now we can go to this top and use our torque formula, 2.56 kilograms times meters squared times 1.047 radians per second squared, and we plug that in our calculator to get 2.68 newtons times meters. So the correct answer is answer choice 1 for question number 5, and it is equal to 2.68 newtons times meters. So, just to recap, remember that if he gave you an object with some mass and a radius, you could go ahead and calculate the inertia. Here we already had it. And then we take out our torque formula. Torque is equal to inertia times angular acceleration. We go back to chapter 9 formulas. So make sure you have all of your angular rotation formulas. Final angular velocity squared equals initial angular velocity squared plus 2 times the angular acceleration times the distance traveled, or here we use final angular velocity equals initial angular velocity plus angular acceleration times time, and we can go ahead and solve for